So this is the problem with respect to the flywheels. So you need to remember this terminology. So he will ask you to calculate the different dimensions of the flywheel rim. So please remember this. So capital D is equals to mean diameter of rim, and R we can calculate if he has given the diameter. So cross section area of the rim is capital A. The material of the flywheel rim, so the density will be given. It is denoted with rho. Capital N is the speed of the flywheel, omega is the angular velocity, v is the linear velocity, for which the formula is capital R into omega. We can also write as pi d n by 60, where d is the diameter and n is the rotational speed. So sigma is equals to tensile stress or hoop stress. It will also be given in the problem. So remember all these parameters. So next, the formula which you need to remember is, so he will ask you to calculate the mass of the rim of the flywheel. So the formula for mass of the rim is mass is equals to volume into density. So pi dA multiplied by rho, which is density. So please remember this formula, mass is equals to pi dA rho. So the flywheel cross section is rectangular. So the cross section of the flywheel rim is rectangular. So we all know that for a rectangular cross section the area is B into T, nothing but width into thickness. So if he asks you to calculate the rim dimensions, then you need to calculate B and T, which is nothing but the width and thickness. So remember this formula also, area is equals to B into T. So we will have a look at the problem related to this. So this problem is a combination of multi-cylinder engine along with the calculation of dimensions of the flywheel rim. So here in this question, the scale is given for a multi-cylinder engine. So 1 mm is equals to 500 Newton meter on y-axis and 1 mm is equals to 6 degrees on the x-axis. So we all know that crank angle will be taken on the x-axis and turning moment will be taken on the y-axis. So the areas are given. So here the symbols are mentioned, plus or minus symbols are mentioned. So minus 30, plus 410, minus 280 and so on until minus 260 square mm. The areas are given. So the engine runs at 800 rpm. The speed of the engine is given as 800 rpm. So engine has a stroke of 300 and fluctuation of speed is not to exceed plus or minus 2% of the mean speed. So fluctuation of speed is n1 minus n2. So it is equal to plus or minus 2% of mean speed, which is n. So n1 minus n2 by n is equals to plus or minus 2%. So in my previous videos I have already told you that if in any question plus or minus some numerical is given, then we need to double that value. So here n1 minus n2 by n is equals to 2 2's, nothing but 4%. So n1 minus n2 by n is nothing but coefficient of fluctuation of speed. So CS value is given as 0.04. So he asked you to calculate the diameter and cross section of the flywheel rim. So capital D, BT are asked to calculate. So he has given the stress value 7 megapascal and density value 7200 kg per meter cube. So he also given the relation between the width and thickness of the rim. So width is 5 times the thickness. So B is equals to 5T is given. So first we need to calculate the delta E, which is nothing but the maximum fluctuation of energy. So for calculating delta E, we need to draw the multi-cylinder engine turning moment diagram. So here it is the diagram of the multi-cylinder engine turning moment diagram. So the values which are given in the question, minus 30 plus 410 and so on. So you follow that sequence. Minus represents the negative loop and plus represents the positive loop. So you draw the diagram. So see, first he has represented with negative loop 30 and again positive loop 410. It is taken as in the same order given in the problem. So after drawing this turning moment diagram, so So we will calculate the maximum fluctuation of energy. For that we need to calculate the energies at each and every point starting from point A to point L. So as we don't know the starting energy at the point A, so let it be capital E. So the energy at capital A is equals to capital E. Next, the energy at capital B. So since in between AB there is a negative loop, we need to minus that value. So energy at B is equals to E minus 30. So E minus 30. Again energy at C. So if we want to calculate the energy at the next point, then we need to consider the energy at the previous point, and we need to consider whether the loop is positive or negative. So if we want to calculate the energy at point C, so the energy at point B is E minus 30, and again between B to C there is a positive loop, so we need to plus that value. So E minus 30 plus 410, since in between BC there is a positive loop, so we got the value E plus 380. Again at energy D, for that calculation we need to consider the energy at C. So the energy at C is E plus 380, and moreover in between CD there is a negative loop of 280, so we need to subtract that value. So E plus 380 minus 280. So on we need to calculate until the energy at L. So the energy at L has become E plus 260 minus 260, so which is nothing but capital E. So please remember that if you calculate the energies at all the points, the energy at the last point, here the last point is L, so it must be equal to the energy at the starting point. So energy at the starting point we have considered as E, so the energy at L has also come as E. So by this we can tell that you have calculated the energies correctly. So if you have got any other value other than E at the last point, then you have done some mistake in the calculation of energies. So after calculation of all these energies, we need to calculate the maximum fluctuation of energy denoted with delta E, which is nothing but the difference between the maximum energy and minimum energy. So out of all these energies from starting point A to starting point L, so if we see the energies, so the maximum energy is E plus 420, and the minimum energy is E minus 30. So subtract those two energies, we will be getting 450 mm square, but energy should be in terms of joules, so we need to multiply it with conversion factor. So he has given that 1 mm is equals to 500 on y-axis and 1 mm is equals to 6 degrees on x-axis. So multiply those two. So 500 into 6 into pi by 180. So it is 52.37 Newton meter. So multiply 450 with 52.37, you will be getting delta E value as 23,566 Newton meter. So after calculation of delta E, we have the formula delta E is equals to mv square cs, where v is the linear velocity. So by substituting all those values, we got the mass of the flywheel as 604 kgs. So after getting the mass of the flywheel, we have the relation mass is equals to volume into density is equals to pi d a rho, as I have already told you. So pi, diameter of the flywheel rim is 0.745. So he has calculated diameter by using the relation sigma is equals to rho v square. So sigma stress is equals to rho density into velocity square. So by that we got the velocity as 31.2. Again for velocity we have the relation pi t n by 60, where t is the diameter of the flywheel ring. So d is equals to 0.745 meters. So by the calculation of diameter, d as 0.745, we can substitute that in this particular formula, pi d a rho. So in the place of d we have substituted 0.745, and moreover he has given the relation that width is 5 times the thickness. So width is denoted with b, so small b is equals to 5t. So a is equals to area is equals to bt. So if we substitute in the place of b 5t, then 5t into t becomes 5t square. multiplied by rho density 7200 is already given in the problem. So only unknown is thickness. So from that relation we got the thickness value as 85 mm and b is equals to 5t. That relation is given in the problem. So b is equals to 5t. 5 into 85 comes to 425 mm. So like this we can calculate the unknown parameters. So with respect to this problem, which is nothing but the combination of multi-cylinder engine and calculation of flywheel dimensions. So let me repeat. First we will draw the diagram, we will calculate all the energies and we will find out delta E. So it is common in most of these problems. So after calculation of delta E, we will be using the relevant formula for delta E, and we need to also remember the formula for mass, which is nothing but pi d aero. So we have calculated the dimensions of the flywheel rim, nothing but small b and small d. So hope you understand. Thank you.